Okay, Google search. So what we'll cover in this lecture, eventually, there we go. I don't know why it does that. No, you're seeing the wrong stuff. There we go. We'll cover how search works, why it's needed, how it's evolved over the years, basic search principles and techniques. Eventually we'll get to some advanced features like customization and Google Instant that they've implemented in the last 10 years or so. All right. So search is something that everybody uses, but people don't usually think a whole lot about how it works. So, simple process, we try to describe what we want, and hopefully the machines deliver what we want. Right? So the example we used this morning was the two founders of Google, Sergey Brin and Larry Page. And if we had internet, we could go and Google and search for them, find their net worth, and find that they're worth about $50 million. And it's a pretty good system at this point, but we can't do it right now because internet is out. So we have that. Anyway, maybe it'll be ready in a minute. So, key point, data that's highly structured, and by highly structured I mean it has a standard format that everything has to follow. For example, you have, in a relational database, you have a table of data, table of records, and every record contains the same fields, and those fields are more or less rigidly formatted. Okay? If you're searching on highly structured data, it's pretty easy to search for what you're looking for. But if data is less structured or not structured at all, it makes it very difficult. So, for example, suppose you're only sorting, your data is sorted on one dimension. Like you have a stack of invoices, you identify them by invoice number. So some customer calls up and says, yeah, I had a problem with my invoice. And the sales, customer service person says, okay, what's your invoice number? And you say, well, it's 123456. And they go into their database and boom, they pull up into, invoice number 123456. Very fast and easy. We'll talk about that in a second. But if it's sorted on multiple dimensions, you can still make it work really fast. For example, name from a phone book, right? It's sorted on last name, then first name in most cases, right? So, you can do that in Paint. Who here has ever used a phone book? Yeah, that's about as many hands as I expected, yeah. In 5 years, it'll be nobody. Anyway, so for those of you that haven't ever seen one, a phone book is a big book full of addresses, names, phone numbers. Okay, so every phone book record has a standard format, last name, first name, and the phone number, and the address. Usually sometimes address, and then the number. Okay, that was the standard way it was done. Now, suppose you want to look up Larry Page in the phone book. Okay, you're going to give him a buzz. He owes you $20 or something. So you're going to call up Larry. How do you do this? Walk me through the mechanics. And pretend I'm a computer who doesn't know anything. How do we go about finding... Yeah, go ahead.
You search alphabetically for page.
How so? What page would I start at? That's not wrong. I'm just saying I'm a robot. I don't know anything. What page do I search at?
Starting at the first page.
I search at the very first page of the phone book?
Numerically through HP. I mean, you're like to go through something.
Okay, so you want me to flip through a bunch of pages until I find the page. That'll work. It's not the fastest, but that'll work. Okay, so here we get into questions about how there are any number of ways to actually do this, right? But this is one way, right? Flip through pages until find page with page, and then scan that page, right? That'll work. What's a little bit faster way we could do? Yeah, go ahead. Okay, but suppose the phone book isn't marked. Suppose it's just an unmarked set of pages. It's still in order. How would I, as a robot, go about doing this? Yeah. No, there's no table of contents even. I mean, I know it's a physical phone book, but usually there are like tabs on the side, but there's no tabs on this one because we're going to generalize the problem. Okay, so how do I go about doing it? Where would I start looking? I would start looking at the L's for page.
No, you would look up the first name, right? The number?
No, phone books are generally sorted by last name. Yeah, last name, then first name.
Just like the P's.
I would start at the P's, right, but where are the P's? Because I'm a robot and I don't know.
It's in the book somewhere.
What's that? They are somewhere. Okay, a little past the middle, right? As a human, I would recognize, oh, you know what? Distribution of the letters, P's a little bit past half. Probably the P's in the phone book start about a little past half too, right? So let's say I started about 60% through. Okay, I might tell my robot to do that. I might tell the robot, estimate where the P's are based on, letter frequency and distribution. And then, okay, I start a little past half. Now what's going to happen is either I overshoot or I undershoot, right? Chances are I'm not going to go straight to randomly to the page that has Larry Page on it. I'm either going to be a little bit after or a little bit before. So suppose I enter the page and I come up on Nelson. Nelson is the name I get. So what do I do? What do I do at that point? I say, well, there's no page here. What do I do? I go back. I go forward, right? So yeah, so basically what do? I grab a pinch of pages and say, okay, yeah, go forward some, right? Grab a pinch of pages. You have some random distribution for that. I grab a pinch and I end up, I don't know, a little bit past the P's. I end up with Quinn, okay? And I know, yeah, it's somewhere between these two, right, page, but basically what I'm going to do is I'm going to bounce back and forth and eventually converge to the point where it is, right? And maybe here's where I find it. Okay? We can understand this pretty easily. And then once I get to the page, I scan the column, same thing, and then I find the actual listing. That's how you do it. Now, a more generalized case of this, if I'm not even going to assume any knowledge of the letter distribution, I can do this. I can start right in the middle of the phone book, and I'm either on one side of it or the other, right? Chances are page is around here. I'll mark it with green, say. Whoop. I'm going to mark it with green. This is where page is. Okay? A little smaller. That's where page is. And I say, okay, I'm going to check right in the middle. Whichever side it's on, I've eliminated half of the search space, right? I've eliminated half of the possibilities. So all this over here, that's gone now, okay? Now next thing I do is say, okay, I know it's on this side. I'm going to cut this in half. And I know I overshoot, I hit Quinn. Everything past that Q, I know it can't be in there. It's got to be somewhere in here. And in 2 steps, I've eliminated 3/4, right? I do another search, boom, I know it's in there. I do another one, and another one, and maybe I find it, right? But basically, in like 5 searches, I've eliminated, something like 97% of the phone book. And if I do a few more, then if I do like 5 more, I've eliminated 99.9% of the pages in the phone book. So even if it's a 1,000-page book, after 10 of those operations, 10 of those go to the middles and see which side I'm on, I figured out what page it is. That's what's called a binary search, right? That's a generalized algorithm for finding a particular thing. And it works on any kind of sorted data. If I have a set of invoices sorted by number or a set of phone numbers sorted by last name, I can use that. All right, but now here, let's make a different problem. Suppose I have only an address and no name. And I want to find the number for that address. How do I find it? Because remember, the data is not indexed by address. Addresses are there, but it's not indexed by address. How do I search for that? Why will it take a while? Didn't say you're wrong. Why is it going to take a while? Yes, because you have to search through the entire fucking book. Okay? That's the only way to find it. If the data isn't indexed on the variable that you're looking for, right? You have no way to do it. There's no correlation between name and address. I got to start with the first one, go all the way through to the end. This is how come systems typically, have a problem with doing alternate index types, right? They specifically ask for invoice number. You can search based on that. You might be able to search based on time or based on customer name, but other things like looking up an invoice based on what items you bought is probably not going to work because they probably don't have the data already indexed on that way. Okay? So the ability to index the data and have it in some kind of sequential order, that's what allows you to do fast searches. Okay, does that make sense? Any part of that not make sense? Okay. So, if you're sorted on one or more dimensions, pretty easy to find stuff as long as you have that dimension that it's sorted on. But if you look at something like categorized then sorted, that becomes a little trickier. You go to Amazon, and let's see if we got Amazon. We got internet now. That's wonderful. Okay? You go to Amazon, let's look through some stuff. We'll go to music, right? Amazon Music, and we'll go to the download store. And if you want to find a particular thing, the site, the way it's laid out here, is not really set up for it, right? They have categories. If I'm interested in a new release, fine, I could probably find that. Okay, or any of these things that for whatever reason are appearing at the top, right? These are probably good options. I can find them pretty easily. But if I'm looking for something different, like say I want to go back and find some, I was doing soundtracks earlier today. If I wanted to find the soundtrack for some movie from like 15 years ago, I'm probably going to have a tough time finding that just by navigating through this list, right? I'm going to basically have to potentially search through the whole thing. That is a problem. Okay. So essentially what they've done by categorization, they've split the phone book into a set of smaller phone books, right? It's not as bad as looking through the complete phone book, but if you're looking for something that doesn't show up in one of those headline points, you're going to be looking for a while, okay? The worst case, though, is where data is completely unordered. For example, web pages. Web pages don't have any sort of inherent structure. I can look at the source code on this, right? This is all the code that's used to construct the web page. And there's just mostly a lot of scripts and then some references to images and not much else. But the point is, there's not one single way to write a web page. There's no guarantee that a web page will have the same kind of data types as any other page, right? It doesn't lend itself well to this indexing problem. And that's what makes online search a tremendously difficult problem. And that's why Google makes so much money, because they were the first operation to really come up with a good way of analyzing this kind of data and comparing one page to another. Okay. So, let's talk about web pages. Basically, web pages have text, some objects, right, like images, buttons, scripts, and then formatting instructions, how these things are going to be displayed. So, text, you can be in a bunch of different fonts, colors, styles, whatever. Object can be included in the page, right? There could be something that's automatically there in the page, or it can be like images that are pulled from external databases, or ads that are pulled from external databases, or in some cases, they can even be automatically constructed by the browser. So you have what's called server-side scripts, where when the server gets the request to create the page, it runs that script on itself, on its own hardware, and says, oh, I need to construct this part of the page. So if I go to Yahoo Finance, for example, I go to Yahoo Finance, and I want to look up historical stock prices for Amazon. I can eventually get it. I mean, Yahoo's pretty slow, but we'll eventually get it, I think. La 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 la, please respond. Let's try again. So slow. There is no top. Well, there is that, but yeah. I didn't have to use it this morning. Yeah, okay. La 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 la. All right, this is why Yahoo lost the. Yeah, this is why they lost the contest, because there I'm mostly just getting news. Well, we'll get it. So hang in there. It's just so fucking slow. Let me try it one last time, then I'm just going to give up because it sucks. Okay. Can I try anything? There we go. Maybe I got to do capitals? That hasn't been a problem before. Okay. There's not been a problem before. So it did go through. Well, one day here we'll get it. Okay. So if I want to get historical data, so right here, right, when it constructs this page, basically it calls the server and says, okay, server, consult with the database, get the current version of Amazon stock price data, and convert it to a chart, right? So if I do like one day, I can see what's gone on for one day. If I want historical data, right, I can go blue and I get like a year's worth of Amazon data, and you can scroll down and see all this stuff like, you know, probably roughly a year. Yeah, about exactly a year. The server calls the database and says, okay, database, give me that data. And then the server takes that data and constructs it into an HTML appropriate format to actually display on the web page. So there's that. Okay. And as we've seen with Facebook, okay, objects can have metadata as well that control whether they're displayed or their preferred size, things like that. So all these web page elements can be combined in pretty much arbitrary ways. So there's no meaningful way to order pages. There's no way to say this page should appear ahead of this other page in some index. You can't rank them like that. Okay. So we'll talk about how pages are actually written. So web pages are mostly written in HTML. HTML stands for Hypertext Markup Language. So a markup language is a way of essentially describing content that's already in the page. And hypertext, that was just a thing for back in the day. You had text, ordinary text as web pages, but you also had what they called hyperlinks. Nowadays, we mostly just call them links. But back then, I guess it was fun to call them hyperlinks because they were links to other websites as opposed to links navigating a site structure. Anyway, HTML relies on tags. These tags are labels that identify a particular object or text format. So, for example, suppose my text is this. My text is the quick brown fox jumped over the lazy dog. Okay? Circa 1990, basically all browsers showed text in default format, and the particular machine would display it in a default format. Okay, so there wasn't much point of special, conveying unique fonts. The kind of computers we had back then were, shit like this. I'll show you the Commodore PET was a popular one in the early 80s. So the Commodore PET was a neat machine in its day. Right, this one, if you look real close, you can see that it has two colors, green and off. So there, and it had one font, and it just displayed the text the way it was. Okay, so because of that, there wasn't a whole lot of need for this kind of funny custom fonts, right? But around 1994, modern-ish web browsers are developed that can display text in multiple formats. So people started writing web pages in those multiple formats, right? Because people like variety, people like different kinds of text. And what you do, for example, if you wanted to show the word the word quick in boldface and jumped over in italics, you could do something like the B tag for bold, quick, and then end the B, end the boldface, brown fox, and then I for italics, jumped over, and then close out I for italics, the lazy dog. Okay? And that was a very, very simple way to do it. So that's what a markup language is. Essentially, you have this text, and the markup part of it is these tags, this opening tag here and this closing tag here, that say, I'm going to display this in a particular special way. Okay? All right. So Little example here, HTML. We'll have more to say about HTML later in the course, but this will do for now. So here's some tags. H1 is a header tag. It's very big. It's like 3 times the height of normal text. H2 is still pretty big, but it's a lot smaller, maybe twice the size. So McDonald's starts selling donuts. Strategy hopes to boost breakfast sales. Then we have a P tag. The P tag creates a new paragraph. So in a surprising strategic move, blah, blah, blah. Then we have donuts. Donuts highlighted, bracketed by boldface tags, the B and /B to close it out. So only the word donuts will appear in bold. Then another paragraph, some text that's italicized, fresh, delicious donuts. And down here at the end, the A is for a hyperlink. But the way it's written now, it's not active. So we're going to copy this into an online HTML editor so you can see what I'm doing. I'm not totally making this shit up. Okay, so online HTML editor. We'll use this one. There's a whole bunch of them out there. They're mostly all pretty good. Okay, so if I copy my text in here, which is what I'm going to do now, you can see it all gets displayed as HTML. So H1 here, this is a big font. H2 is a header. It's still bigger than regular, but not as big as H1. The word donuts, as promised, is bold. Fresh, delicious donuts, as promised, is italicized. And here, we have some text, mcdonalds.com donuts. All right, but I haven't given a link to this, so it's not showing up as a hypertext, as a hyperlink. If I want to, I could put href, right, hyperlink reference, and I can say equals http mcdonalds.com. Okay? And then I've made this into an active link that I could conceivably click on and go someplace. All right? So that's our quick intro to HTML. Whatever formatting option you have, you enclose it inside brackets. You'll see here it supplies the closeout paragraphs for me. It's helpful. Okay? All right. That's fine. Notice also some of these have been a little bit deprecated. They don't always work exactly anymore. So boldface, for example, and italics, those are generally done nowadays using style elements, not the B and I that I used. So now here they have strong for that one, for example. So the syntax has changed over the years, but yeah, still takes it. Excuse me. Okay, questions on any of that? All right. So now let's spend a few slides talking about how online search works. So first off, text matching is the core technique, right? You look at what page is on the text, you look at what text is on the page, and see how it matches up with the search term somebody enters, right? So big thing is page titles. If the words appear in a page title, it's a pretty good sign that that page is about what you're looking for. So that's a good sign. Other stuff, headers. Headers are better than plain text, right? Ordinary, non-header text. And then plain text too, it looks for that. So it goes through all the text and sees, oh, we find some matches. And if you find page titles or headers that match, that's more significant than regular text. Also, in some cases, you can find matches in image or other metadata. So, if I, for example, want to find images of jack-o'-lanterns, Google has a lot of algorithms running, but I'm pretty sure they don't have an algorithm specifically designed to try to recognize jack-o'-lanterns as such from ordinary pumpkins. Instead, if I do an image search, right, I do jack-o'-lantern, it's going to look at the tags that people have put in the image. So when people put the image on the page, it could have some associated text describing what the image is of, right? It is of jack-o'-lanterns. And you might put other tags in there like pumpkin, Halloween, spooky, whatever. You might do stuff like that. So if I do jack-o'-lantern, boom, right? Comes up with this. And Google, again, is not combing through all these various pictures of pumpkins carved up on the internet and say, oh, this is a jack-o'-lantern, that one isn't. It's basically from user identification, right? Whoever creates it. All right. Some of those are cool, not so much. That's generally the style I do, though I haven't done green lights much. Maybe I will this year. All right. All right. Other stuff. Accepting imperfection. So, 20 years ago, if you ran a search, you pretty much had to find exact term matches. If you didn't find exact term matches, the pages wouldn't show up. And it could be something as simple as All right, what's a good example? Suppose you were looking for information on, I don't know, lampreys. Right, you guys know what lampreys are? Oh, they're nasty things. Let me show you. Lampreys are like giant spiky mouth eels that latch onto the sides of fish and suck their guts out. Not making this shit up. Look at that, it's nasty. All right? That's life in the lake. All right. Anyway, so suppose you're looking for lampreys, right? If you, circa 1999, if you look up the term, do a search on lampreys, you would only find pages that have lampreys. You very well might not find a page that only had lamprey, right? It was a very precise text match. Eventually, they started relaxing on that a bit, and then other things followed. But a good example, suppose you're taking a history course 20 years ago, and you got to write a paper on World War I, so you get online and try to start searching for stuff because it's a long walk to the library. What are some synonyms for World War I? The Great War, right? That's usually what they call it in England. What else? Battle? Probably not. There have been other battles. What if I say WW1, right? Or WW Roman numeral 1, right? Yeah. Or what else? Well, no, those are different wars. Those are different wars. Okay? Or the First World War. Okay? If all I'm doing is Googling for World War I, if pages don't specifically refer to it as World War I in text, none of these other things are going to get caught. Okay? This is a problem. This is a problem that, has been, resolved for some time, but still. Basically what Google does, when it maintains its index of matching terms, it recognizes now that these 4 terms are, for all practical purposes, equivalent with the first one. Okay? Now, there's some related stuff to that. So, for example, if I'm searching for bugs, and that's all I type in, right? It's a reasonable synonym for insects, right? Strictly speaking, bugs and insects, not perfect correlation, right? Bugs is more a catch-all for creepy crawlies, but yeah, close enough, right? Close enough for IDS 200. But if I do an association, like computer bugs, I don't mean robot bugs, right? And I don't mean bugs that actually live inside computers. I mean flaws in the software, right? That's what computer bugs are. So Google at this point recognizes computer bugs is a synonym for software bugs. Likewise, it's tolerant of misspellings. For example, if I type in BGUS, that could plausibly be I skipped over the O in bogus, right? I just, typed in fast and I missed that. Or it could be I transposed the letters in bugs. Either of those could be plausible failures. Now, the way Google detects in the long run which of these misspellings it's probably going to mean is it looks up, oh, somebody typed in this, and then they say, that's not what I'm looking for. I go back and I retype what I'm looking for, because that's what humans do, right? Humans say, I type in BGUS, I get a bunch of nonsense, I go back and I type in bugs again. Google recognizes, oh, you meant bugs. So BGUS sometimes means bugs. Okay? Now, if we do that now, if we do BGUS now, we generally get Bowling Green State University. We didn't always. That only started happening a couple years ago. So BGUS, Bowling Green State University, there's a thing, right? But if I add on the magic word software, it says, oh, context. You mean software bugs, right? You don't mean software that they use at Bowling Green State University. Okay, so the search has gotten a lot better. It's no longer exact term matches, uses a lot of equivalences. Okay. Now, excuse me. Ideally, user search terms would correspond uniquely to the desired page, right? You would pick up a set of words that appears on one and only one page. But in practice, that's not feasible, right? And I'll prove that. So let's think of 4 of the craziest words I can think of. So I'm going to toss out one, ziziva, right? Which is a bug or a plant that the bug eats. It is the last alphabetical word that's playable in Scrabble. What else? Give me a weird word. Weird word. Silastic. Okay? Silastic is a word. What else? Oh, quokka. Quokka is some kind of small New Zealand mammal. One more weird word. Let's not make it an animal because we got a couple of those already. You don't know any weird words? Oh, syzygy. Okay? So 4 weird words, right? These are words that are so weird it's pretty unlikely they'd appear on more than one page. 8 results. Even with the craziest shit I can think of, we still get 8 results, right? Here's an article about, now, they're not all exact matches either, so that's part of the problem. As we see here, we get matches that only include one of the 4, right? But still, as far as Google's concerned, yeah, there could be multiple ones. Okay, here's like a list of like the complete vocabulary of the universe. This is probably like for dictionary attacks on websites. Same thing here. Random list of really, really weird words, and Ziziva and Silastic and Syzygy and Quokka appear on all of them. Same thing here, right? Random list of words, and here they show omitted some entries very similar to the 10 already displayed. So even so, right, there's a lot of pages with even really weird words. You do stuff like sports you get upwards of like 20 billion pages. Right, 21 billion. If you search for porn, you probably get like 100 billion pages, right? Yeah. Anyway, just saying. Yeah. Because I know how millennials are. It's all about avocado toast and internet porn. That's what I hear. Anyway, all right. So the point is, right, most searches you enter, there's going to be a whole lot of pages. Google has to figure out which ones it's going to show you. For example, if I have the word shoe sale could be found on a shoe retailer page, could be found in a news article about a shoe sale, could be separate sentences or paragraphs within a completely irrelevant page, right? Some extract from some random novel, and on one page they have the word shoe, and another page they have the word sale. So, Google uses context, the way words appear on a page. So, first thing, terms appearing in a page title are considered pretty important, much so than regular text. Next thing, distance and sequence. The 2 words together, shoe sale, Google's been doing this for long enough that they recognize shoe sale is a thing. They are 2 words that often appear together. So, if there's the word shoe and sale together, that's going to be ranked ahead of these shoes are for sale, where the 2 words are there in order, but they're separated. And that's going to outrank the case, the third sentence. I went to Target for their annual sale on socks. Ironically, I lost a shoe there, right? The 2 words are both there, but they're in reverse order, and they're even more widely separated. Okay, so those are all factors that Google considers. And to a point, they consider repetition as well. All right. Likewise, results for a term can be affected by other terms and by user context. So, if I'm looking for the word Cubs, if I'm doing a search for Cubs in Chicago, chances are I'm going to get stuff about the Chicago Cubs. But if I'm doing it in, say, Los Angeles, right, if I'm looking out there, it probably isn't about the Chicago Cubs. It might be that there's just some zoo nearby, they have some lion cubs, bear cubs, whatever, right, and there's an article about that. Also, Google uses location and history. So if I do this, right, suppose I want to learn about Ethernet, and I say to Google, I'm going to search Ethernet, okay? And here I get a little blurb at the top. I get a little knowledge card that says, okay, blah, 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 this is what Ethernet is about. Now, at this point, when I type what is, it immediately says, oh, you're probably going to follow up with what is Ethernet or network or cable, something like that. I get a lot of Ethernet-related things based on my recent search history, okay? So Google does that too. All right, let's see. So I'll do 2 more slides and we'll call it a day. So, intuitively, if you can come up with less common and more precise words, that's probably going to give you better focus on what you're looking for, right? You're going to get fewer matches. The really relevant matches tend to be closer to the top. So, for example, I grew up in Rockford, which most people consider a shithole, and I was there during the, in 1982, we had a little window of Rust Belt greatness where we had the highest unemployment rate in the country. So, if you look up unemployment statistics, right, unemployment statistics, you mostly get federal data, right, from the Bureau of Labor Statistics, stuff like statistics, okay? I get a little knowledge card up here, and I get a lot of, blah, 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 national level news, whatever. If I look up unemployment statistics 1982, well, then it's a lot more focused, right? I get a knowledge card that's a little different. There was a recession going on then. It talks about that. I get some historical data, because if I'm looking for a particular year, and that batch of historical data contains 1982, it shows up. And I get some articles, from the time, whatever. Okay? But if I specifically want to look about Rockford, Illinois, right? Then I get some stuff, some things about what was going on there. Various data, early 80s recession, Wikipedia article about Rockford, how shit was bad. Okay, here's a newspaper article from 1982. So stuff like that, right? If you can really focus it, you can come up with what you're looking for. Yes?
Using the and or, those are the Boolean operators?
Yeah, that's what they're called. Or just logical operators.
Does that also help refine your search?
It can. Well, an and will, right? So if you're doing a search where you're looking for A and B, that means you're looking for a page that has both of those. So that's actually gonna narrow your search, because you say it has to have all those. But the and is rarely used because it's implicit, right? If I'm looking for a page that includes all those things, I just write all those things, and it's already looking for all of them. But if I do A or B, then I'm a little bit more flexible, right? So if I have A or B, this is the case where, again, Google kind of implements this at this point anyway. You saw when I did the 4 words, it was turning up pages that only had one of them. So Google already kind of does that now anyway. So yeah, in principle that is supposed to help, but in practice, Google implements a lot of that anyway. Okay, quick, one last slide, because I want to catch up to where we were. So, way back when, the internet basically operated like a great big message board, okay? And you could navigate it like a file folder. The reason was there weren't many information repositories. Basically, there were some universities doing research programs. There were some government and other military and other government facilities that kept data. That's what there was. So it wasn't like there was this huge range of addresses, right? And each one of those locations had essentially a file folder of what they had. So they had their various research projects, and whatever there were, you could navigate that through a file folder. So if you went to like MIT, their website, you could say, okay, I'm looking at MIT, here's categories. They got stuff in physics and computer engineering and chemistry and astronomy. And I can look in whatever folder. If I have access, I can find the particular research operation that I'm looking for, and I can pull up that data. So, because there wasn't a lot of data and because it was all pretty neatly organized into categories, you could basically navigate the internet the same as you navigate a file folder these days, as long as you know what's in the folders. But more pages, more problems. So number one, huge proliferation of websites and data, right? So we have a quick stats here. These are the number of websites, starting from basically nothing in the year 2000 up to over 1 billion, a few years ago. The consolidation. Yeah. Anyway. Yeah. A lot of that, actually, I'll address that. Probably a lot of the dip is due to what are called spam pages, basically garbage pages that got shut down because they weren't getting any traffic once Google figured out how to not send people there. That's my best guess as to the dips. Okay. The other thing, content not easily or precisely categorized, right? You have, for example, you have some guy writing a blog. Every blog article might be on a different topic. How do you categorize that blog into one, neat category? It just stops working anymore. So, with all these pages and variety of content types, navigating the internet became very difficult. So you needed operations like Google to help people find stuff. All right, and that's all I got for you. We'll come back on Wednesday.